seconds and counting. Guidance internal, 15, 14, 13, 12, 11, 10, 9. Engines on, 5, 4, 3, 2, launch commit, surgeon. Go.
Flying away from the Earth and exploring outer space. This has been our dream for generations. In the 1960s, man entered space successfully, marking the dawn of a new era. At the turn of the 20th century, man invented aeroplanes, which took people off the ground and into the sky. The aeroplane has now become a common means of transportation. But why is it that it wasn't until over 60 years later, in the 1960s, that man could fly beyond the atmosphere and enter into gravity-free space?
The reason is that the rocket must have sufficient propulsion force to free itself from the gravity of the Earth and push itself out of the atmosphere into space. And in order to build a rocket with a strong propulsion system, sophisticated electronics and a delicate engine, we need knowledge and skills in various aspects of science and technology. We all know that after throwing a tennis ball upwards, the ball falls back quickly. This is due to the effect of gravity. Blow a balloon and then release it. We find that the balloon flies freely in the sky until all the air in the balloon is ejected out. Then the balloon falls back onto the ground.
Observe closely and you'll find that the direction of the balloon when flying in the air is opposite to the direction of the ejected air. To force the air out of the balloon exerts a force on the air. This is known as action force. At the same time, the ejected air exerts a force on the balloon equal in magnitude but opposite in direction. This is known as reaction force. It is the reaction force that makes the balloon fly in the sky in the opposite direction.
A water rocket operates on a similar principle. The compressed air in the water rocket acts on water and forces the water out of the rocket. Meanwhile, water has a reaction on the air in the rocket. This propels the water rocket and makes it fly upwards.
The fact that a rocket can free itself from the gravity of the Earth and rise upwards can also be explained by action and reaction. Gas is ejected from the rocket's engine, resulting in a strong action force. A force of the same magnitude but opposite in direction arises at the same time to push the rocket.
Escape velocity from the Earth and cross the 385,000 kilometer expanse route to the Moon.
In space, there are no supplies of air or oxygen. Combustion is impossible with fuel alone. So a rocket must bring with it an oxidizing agent to produce oxygen. The most common oxidizing agent is liquid oxygen. There are two major types of fuel used by rockets, solid fuel and liquid fuel. Rockets using solid fuel are simpler in structure and can create a strong propulsion force. A rocket using solid fuel must be able to withstand pressure more than 10 times that of atmospheric pressure. So, a rocket using solid fuel cannot be used to launch a manned spaceship.
But a rocket using solid fuel can be used as a supplementary propelling rocket to add to the propulsion force required for the launch of a space shuttle.
We have main engine ignition, 3, 2, 1, and solid motor ignition and liftoff. Liftoff of the first operational space shuttle mission with 2 satellites on board, and the shuttle has cleared the tower.
After exhausting their fuel, the 2 propelling rockets using solid fuel detach themselves from the space shuttle and land in the sea with the help of parachutes. They will then be recovered, repaired and reused.
Kennedy, and we're towed in and are in pretty good shape. So I think this is clear-cut proof that we do in fact.
The structure of a rocket using liquid fuel is more complicated. The fuel is stored within the rocket and is ready for combustion in the engine. The time of combustion is also longer. This is useful in controlling the propulsion force and speed of movement of the rocket, helping the spaceship enter into and leave its orbit of the Earth. Liquid hydrogen is the most commonly used liquid fuel for rockets. Currently, all manned space expeditions are carried out with rockets using liquid fuel. Liquid hydrogen is an environmentally friendly fuel. Hydrogen can be decomposed from water. After combustion, liquid hydrogen combines with oxygen to turn into water and doesn't pollute the environment.
In the early days, due to restraints in technology, rockets could not be reused. The size of the cabin for carrying people in a rocket, whether large or small, that returned to the Earth in the end was only a small portion, usually less than 20% of the entire rocket.
If we look at the structure of a manned rocket, we can see that most of the rocket is used to store the fuel and oxidizing agent needed to propel the rocket. The remaining portion is the space cabin, control system and propelling engine.
A rocket is largely different from a jet plane. A jet plane flies only in the atmosphere of the Earth. The structure of a jet engine is entirely different from that of the engine of a rocket. The propelling engine of a jet plane takes in air in front, accelerates it with the jet engine, and jets it out in the back. The principle of action and reaction applies in propelling the plane forward. The propelling engine and fuel of a jet plane occupy only a small portion of the entire plane.
The goal of placing an American in orbit was realized by
A rocket, on the other hand, flies into space.
powerful Atlas D rocket.
The engine of a rocket has to generate a much greater thrust than that of a jet plane. Also, a rocket has to operate in an environment without air. Therefore, most parts in a rocket are used to carry liquid fuel and an oxidizing agent. The speed of a rocket is different from that of a plane. Therefore, a rocket has to have a unique design. For most of the time, a jet plane flies slower than the speed of sound, but a rocket has to move forward at a speed several times that of sound to free itself from the gravitational pull of the Earth and explore outer space.
The outer design of a jet plane is also different from that of a rocket. A plane flies within the atmosphere of the Earth, so a plane must have a streamlined design to minimize the friction caused by air when moving forward, and to allow the wings to lift the plane. Meanwhile, the engine accelerates the air that it takes in and jets it out at the back to propel the plane forward.
The flying speed of a rocket is even greater. Therefore, a streamlined design is necessary to reduce the air friction when the rocket ascends. The tops of all rockets are in the shape of a cone, but the designs of the cabins for space explorers inside the rockets differ according to their functions. A rocket with a cabin carrying people has to go through the atmosphere to return to the Earth, so it has to be in a streamlined shape to reduce air friction.
Gemini 8 was ordered to return to the safety of Earth.
But if it's planned to only fly in space where there is virtually no air, it's not necessary to consider air friction.
Rocket cabins and spaceship explorers may have strange shapes as required by their tasks. For example, the space cabin for people that lands on the moon is like a beetle, whereas space explorers targeting other planets may have unusual shapes. There's no need for a streamlined design.
It will orbit Jupiter and release a probe to study its atmosphere. With the exception of Pluto, space probes have visited every
With a strong engine and sufficient fuel, a rocket functions on the principle of action and reaction and accelerates to the first cosmic speed, that is 7.9 kilometers a second. This speed allows the rocket to go into space and orbit around the Earth. But to escape from the gravity of the Earth, the rocket has to reach the second cosmic speed, that is 11.2 kilometers per second. If a rocket has to fly away from the solar system, it has to attain the third cosmic speed, that is 16.4 kilometers per second.
Did that faint vibration continue through the deploy, or did it stop when you deployed?
When the rocket enters space, it carries out its tasks as planned. These include sending a satellite into a specific orbit, sending an unmanned explorer to other planets, or allowing astronauts in a space shuttle to carry out specific tasks.
Since the Earth is protected by the atmosphere, life on Earth is unaffected by fatal radiation from outer space.
If astronauts enter space without appropriate protection, they'll quickly be harmed by cosmic radiation. All space shuttles are equipped with provisions essential to astronauts, including breathing apparatus as well as systems to maintain an even temperature.
On the flight deck, we're doing everything.
When astronauts travel around the Earth in a spaceship, they're in a state of weightlessness. In the space cabin, there's no distinction between the top and the bottom, and nothing is fixed. All objects float in the space cabin. Astronauts are no exception. Astronauts move around in the cabin by grabbing fixed objects in the cabin. In a weightless state, the flesh of the astronauts gradually shrinks. The calcium in their bones also reduces gradually. Therefore, astronauts have to exercise appropriately to keep themselves healthy. In a weightless state, all objects float in mid-air. Even air cannot flow. Therefore, an air pump is necessary to maintain the supply of fresh air in the cabin. In the space cabin, the air has already been pressurized. Therefore, astronauts do not have to wear special spacesuits, except in an emergency. But if astronauts have to work outside the space cabin, they have to wear spacesuits to sustain life. In space, the direct rays from the sun can raise the temperature to over 130 degrees Celsius. In places that the sun's rays cannot reach, the temperature falls to as low as minus 120 degrees Celsius. So the spacesuit must be capable of resisting extreme temperature changes. The spacesuit must also be strong enough to resist damage by cosmic dust. On the Apollo space mission, the innermost and outermost layers were made of glass fiber fabrics. In between, there were 7 layers of aluminium-plated plastic sheets. There were also 6 layers of glass fiber fabrics in between the plastic sheets.
A spacesuit is airtight. A circulation system is built in to supply oxygen and to take away the carbon dioxide and vapor exhaled by the astronaut.
There is also a temperature-adjusting device in the spacesuit to prevent temperature increases within the suit as a result of trapped body heat. In a spacesuit, there are also communication devices and a thermometer and sphygmometer to gauge the physical condition of the astronaut. If an astronaut has to stroll or carry out maintenance work in space, he has to put on a knapsack for flying with a gas propeller to help him complete his task. After completing their tasks, astronauts prepare for their journey back to the Earth. First of all, they activate the anti-propelling rocket to reduce the speed of the spaceship. The spaceship then leaves the original orbit and heads towards the atmosphere of the Earth. At this moment, the astronauts have to face another challenge. Will the hull of the spaceship be able to withstand the extreme heat of several thousand degrees caused by friction between the spaceship and air when the spaceship goes through the atmosphere of the Earth at supersonic speed? This temperature is high enough to melt metal. Therefore, the outer case of a spaceship is designed with layers of different materials to resist heat. For a space shuttle, expensive heat-resistant ceramics are used to protect the astronauts inside, ensuring that they can return safely to Earth. For millions of years, man has got used to the living environment on Earth. Why is man trying to explore a totally unknown realm?
This is an important factor for the survival and continuation of the human race. To challenge oneself, to face the unknown, this is a human instinct.
The construction of space stations is a step towards this direction. The International Space Station under construction is a joint venture of several countries. It's expected to be completed in 2005. The space station can accommodate 7 astronauts or scientists at the same time. It serves to test whether man can adapt to life in space in the long term. It also helps to bring about new developments in resources on Earth, in medicine and in industry. People have an endless yearning for knowledge. Curiosity and self-challenge are also motivating forces in human progress. Things that are impossible now may become very common in several decades. Let's think about it. A century ago, man was only just inventing the aeroplane. Now, 100 years later, the aeroplane has become an indispensable means of transportation. The pace of scientific development is so rapid.
Looking into the future, the exploration into space will be the greatest challenge for the human race.